So this is a cool problem. It's sort of like a joke. You can only see it once and really enjoy it. So I hope you should probably pause the video and think about it for a while, because it's much more fun if you get the answer. So the question is, given that the three sides of the triangle are all different integers, what is the smallest possible value for the perimeter of this triangle? So for integers, something like 1, 2, 3. Well, how about 1, 2, 3? 1, 2, 3 would be the smallest possible way to have three positive integers, right? But the problem is that the number triple 1, 2, 3 fails the triangle inequality. The triangle inequality states that any two sides, when you add the lengths, should be bigger than the third side. For example, A and C added should be a longer trip than the shortest trip possible, right? Between 2 points, the shortest distance is the straight. Therefore, this has to be longer. 1 plus 2 equals to 3. So that means that if you have a line 3 long and you have a 1 and a 2, you can't lift up this point. Cannot lift it up. So you don't have a triangle. So that's the triangle inequality. And so 1, 2, 3 fails that. So now we have to slowly increase these numbers until we find the smallest one that works, and that's going to be the smallest perimeter. This would have been a perimeter of 6, but it didn't work. So how about 1 to 4? Well, 1 to 4 is even worse, right? 1 plus 2 is only 3, so we cannot raise this third number. We're not going to get reasonable. We're not going to get any triangle, so we have to do more than just increasing the last number. Let's fix at least the smallest side to be 1. If the smallest side is 1, 1, 2, 3 we had, 1, 3. So if the two shortest sides are 1 and 3, then their sum is 4, so the longest one has to be less than 4, so that's not going to work. 1 and 3 does not work. How about 1 and 4? If the shorter two sides are 1 and 4, that means that the third side has to be less than 5. So less than 5, that's 1, 2, 3, or 4. Now the sides are all different, so 1 and 4 are out, so we have 1, 2, 4 and 1, 3, 4. And none of them works because 1 plus 2 is 3. This is not less than 3. 1 plus 3 is 4. This is not less than 4. As a matter of fact, if we insist on the shortest to be 1, then the next shortest is n for an integer. Then the third one has to be, if we insist this not to be the longest, it has to be bigger than n, but on the other hand, less than, so it has to be bigger than n, but also it has to be less than n plus 1. And it has to be an integer. So how can we have an integer between n and n plus 1? So 1 cannot be a side in a triangle with 3 different integer sides. It's just not possible. So 1 is out. Okay, so then let's roll up. The smallest case we can possibly think is then 2, 3, 4. Right? The smallest number, if it's not 1, then it's 2, and then they have to be different, and then we just go up 1. Now, is this a triangle? 2 plus 3 is 5. Well, let's see. So 2 plus 3 should be bigger than 4. 5 is bigger than 4, right? 2 plus 4 should be bigger than 3. That's true too. And 3 plus 4 is, of course, bigger than 2. So when we are checking the triangle inequality and we know all 3 sides, then basically just match the 2 shorter one against the longest one. The other ones are automatically already true. So I believe 2, 3, 4 is the smallest different integer-sided triangle. So the perimeter is then 9. So the question was, what is the smallest perimeter? And the answer is, it has to be at least 9. Thank you for watching.